All right, strap in, everyone, because today we're going deep into where large language models, those AI heavyweights, meet the intricate world of graph data.
Yeah, it's fascinating stuff and pretty crucial intersection too because, graphs are everywhere.
Totally.
They represent those complex
Yeah.
relationships in everything from social networks to financial markets, you name it.
Exactly. And lucky for us, we've got our hands on some brand new research straight from Google.
Ooh,
It's a paper called Talk Like a Graph, Encoding Graphs for Large Language Models.
catchy title.
Yeah, and it's basically all about trying to, well, teach LLMs a new language.
Like giving them a crash course.
The language of graphs.
Now, that's a challenge, right? Because LLMs, they're built for text.
Yeah.
Getting them to understand all those connections and structures within graph data,
Right.
that requires some clever workarounds.
So how do you even begin to translate something visual and complex, like a whole network of relationships, into something an LM can actually digest?
Well, that's where encoding comes in.
Oh, okay.
Think of it as finding the right way to describe a graph, but using text.
So like a translation process.
Yeah, finding a way that really captures the essence of its connection
Okay.
and its nodes.
So it's like creating a set of instructions almost, a code the LLM can decode
Yeah, you could think of it that way.
to understand what the graph is actually representing.
Precisely.
Interesting.
And the research dives into some really innovative encoding methods, some pretty out there stuff.
Oh, really? Like what?
Well, they even tried representing graphs using characters from pop culture, believe it or not.
Wait, are you serious?
Oh, yeah.
Like using, say, characters from a TV show to explain a complex financial network?
Yep.
That's wild.
It is, but, the million-dollar question is, did it actually work?
Yeah, I was just going to ask that.
And what they found is that the way you choose to encode, that method you pick, had a huge impact on how well that LLM performed.
So some methods were better than others.
Much better. Some were far more effective at conveying the graph's structure
Okay.
and its meaning.
So it's not just about feeding the LLM information.
Right.
It's about presenting it in a way, in a language
Right.
it can actually grasp.
Yeah, exactly.
It's like finding the right communication style for these AI systems.
That's a great way to put it.
Fascinating.
And it's also fascinating because they discovered that LLMs, they're not perfect.
Oh, okay.
They seem to have certain biases about what a typical graph should look like.
Riley.
Almost like they're making assumptions based on all that training data they've been fed.
So even when dealing with something as, I don't know, abstract as graph data,
Right.
they're not immune to those quirks we see in other AI systems.
Not at all. And it really highlights the importance of understanding those biases, making sure that the LLMs are trained on diverse and representative graph data sets.
So that they're getting a good balanced education.
Yeah, you could say that.
So to really put these LLMs to the test, right, the researchers created this special benchmark they're calling GraphQA.
And GraphQA is essentially a set of graph-related tasks, designed to see how well an LLM can reason about and then actually manipulate graph data.
So what kinds of tasks are we talking about here?
Oh, things like finding connections between nodes, right? Or detecting cycles, or counting elements, all sorts of things.
And these aren't just theoretical exercises, I'm guessing.
Not at all.
These have real-world applications in, well, probably a ton of fields.
Yeah, absolutely.
So GraphQA is like an obstacle course for these graph-aware LLMs.
Yeah, you could think of it that way.
Pushing them to show what they can do.
Exactly.
In a practical sense.
Putting their skills to the test. Yeah, and that's where it gets really interesting because those tasks, they're not just some theoretical exercise.
Yeah.
They actually translate directly to some pretty amazing real-world applications.
Okay, now you've got my attention. Give me an example.
Okay, so let's say knowledge representation.
Okay.
Knowledge graphs are massive, right? Repositories of facts and relationships. But even the best ones have limitations.
Like what?
They struggle with things like the nuances of human language
Okay.
and ambiguity.
So like understanding that the word apple could mean a piece of fruit.
Right.
Or a tech company.
Exactly.
Or even a record label.
Yeah, depending on the context.
Right, it's all about context.
And that's where LLMs come in.
Okay,
with their ability to process and understand natural language. I mean, they could be absolute game changers here.
So if you integrate them into knowledge graphs,
right,
you could have systems that are way more flexible.
Absolutely.
And capable of really grasping the complexities of human knowledge.
That's the idea.
Wow.
It opens up so many possibilities, things like advanced search engines
Okay.
that really understand the intent behind your queries.
So not just matching keywords anymore.
Exactly. Or personalized educational tools
Oh, interesting.
that adapt to how you learn best. Or even AI assistants that can give you truly insightful answers based on a deep understanding of a topic.
So we're talking about AI that can not only store information, but actually reason about it.
Right.
Make connections that a traditional knowledge graph might totally miss.
Exactly. Pretty incredible, right?
Yeah, it is. It also makes you wonder about network analysis.
Oh, yeah.
I mean, we're dealing with these increasingly complex networks everywhere we look.
Everywhere.
From social media to financial systems. Could LLMs help us make sense of all that interconnected data?
Absolutely. Imagine an LLM that could analyze a social network.
Okay.
And not just identify influencers, but actually predict how information's going to flow.
Wow.
Or how an idea might go viral.
That would be powerful.
Or think about financial markets. An LLM could potentially spot patterns that indicate fraud.
Oh, wow.
Or even predict market trends with more accuracy than ever before.
So we're talking about AI that could help us understand and even predict complex events by analyzing the relationships within these massive networks.
Precise.
This is pretty mind-blowing stuff.
Yeah, it is. And it doesn't stop there. Think about urban planning.
Okay.
LLMs could help optimize traffic flow.
Oh, that would be amazing.
Or predict the impact of infrastructure changes.
Huge implications.
Or healthcare. Analyzing patient data to identify potential health risks.
Wow.
Or even personalized treatment plans.
It sounds like we're on the verge of a major breakthrough
I think so.
in how we use AI to understand and interact with the world around us.
It's really exciting, and it all comes back to that idea of teaching LLMs to talk like a graph.
Now, all this potential is exciting.
Yeah.
But it also raises some questions for me.
Like what?
Well, the researchers focused on, relatively basic graph tasks in this paper.
Right.
What happens when LLMs can tackle even more complex graph problems?
That's the next frontier, isn't it? It's almost mind-blowing to think about.
Yeah.
Imagine LLMs that can not only understand the relationships within a single graph,
Okay.
but can actually analyze and reason across multiple interconnected graphs.
So like understanding how events in the social sphere might influence financial markets.
Exactly.
Or how changes to one part of a city's infrastructure could ripple through other areas.
You got it. It's about connecting the dots on a whole new level, uncovering hidden patterns and insights that we could never grasp on our own.
That's incredible. But it could also be, I don't know, dangerous.
Oh, yeah.
If it falls into the wrong hands.
You're absolutely right. It's like any powerful technology.
Right.
There are risks we have to consider.
Yeah.
We need to be thinking about potential biases, making sure these advanced LLMs are used responsibly and ethically.
So it's not just about pushing the boundaries of what's technically possible.
No.
But about creating those ethical frameworks to guide the development and use of this technology.
Absolutely. We have to make sure these advancements benefit humanity as a whole.
Right.
And aren't used to make existing inequalities worse.
Or create new ones.
Exactly.
Okay, I'm starting to see the bigger picture here. We're not just talking about incremental improvements.
Right.
This is a fundamental shift in how we approach problem solving and decision making.
It really is. And it all starts with this seemingly simple idea.
Teaching LLMs to understand the language of graphs.
Precisely.
It's been a fascinating conversation, but let's step back for a moment and think about our listeners.
Okay.
Why should they care about all this?
Yeah, good point.
What are the practical implications of this research for their lives? I mean, this isn't just some abstract concept happening in a research lab somewhere.
Right.
This is about really changing, like fundamentally changing how we interact with information, how we solve problems.
Imagine a world where AI can kind of seamlessly guide us through those complex systems. Personalize our experiences, maybe even accelerate scientific breakthroughs.
Okay, now you're speaking my language.
Right.
Give me some tangible examples here.
Sure.
How could this tech actually impact, like, our everyday lives?
Right. Okay, well, let's take personalized recommendations.
Okay.
Right now, most of those recommendations are based on pretty simple patterns.
Yeah.
In your past behavior, what you've clicked on, what you've bought.
Right.
But imagine an AI that understands not just what you've done, but the reasons behind your choices, the deeper connections in your preferences.
So it's like having a friend who knows you so well
Yeah.
They can recommend stuff you didn't even know you wanted.
Exactly. Or think about education.
Okay.
Imagine an AI tutor that can tailor lessons to how you learn best.
Oh, wow.
Identify your knowledge gaps, even anticipate your questions
That would be amazing.
before you even ask them.
Yeah, that would revolutionize learning.
For students of all ages.
Absolutely.
And let's not forget about healthcare. We touched on drug discovery earlier.
Right.
But LLMs could also help us diagnose diseases much earlier.
Really?
Personalize treatment plans, even predict potential health risks.
So we're talking about AI that could potentially save lives.
Yeah, it's pretty amazing stuff.
I'm getting pretty excited about the future here.
I know, me too.
But let's circle back to the research for a second.
Okay.
What were some of the key takeaways from that Google paper?
Well, one crucial finding is that the way we talk to LLMs about graphs, it really matters.
Okay.
Different encoding methods can have a huge impact on their ability to reason about graph data.
So it's not just about giving them the information.
Right.
It's about how you present it.
Exactly. It's about presenting it in a way they can really get.
So like finding the right communication style.
Yeah, you could say that.
Speaking their language.
And the research also highlighted the importance of the graph's structure itself.
Okay.
LLMs, they can still have biases based on their training data.
Right.
So we need to keep that in mind when we're designing these graph-based AI systems.
Yeah, I mean, it makes sense, right? They're not immune to those biases.
Exactly.
We see it in other AI.
We do. So we need to make sure these systems are developed responsibly and are used ethically.
Absolutely. Okay, I think I'm starting to grasp the bigger picture here.
Good.
This isn't just about graphs and LLM.
Right.
It's about this whole new era of AI.
Yeah.
One where these systems can actually reason about these complex relationships.
Absolutely.
And help us tackle some of, well, humanity's biggest challenges.
It's really exciting. And remember, we're just at the beginning of this journey.
That's true.
That research we talked about.
Right.
They focused on pretty basic graph tasks.
Right.
Imagine what's possible when LLMs can handle, really complex real-world graph problems.
That's mind-blowing.
It is. The implications for fields like social network analysis,
Yeah.
finance, even urban planning are huge.
It's almost overwhelming to think about.
It is, and it raises a really important question for you, our listener.
What's that?
What world-changing applications can you imagine? What problems in your field, in your life, could be solved if AI could truly understand, like really understand the interconnectedness of data?
It's time to start thinking beyond those traditional approaches.
Right.
And embrace the transformative potential of this graph-aware AI.
Absolutely. And that's it for today's deep dive.
Yeah, that was a fascinating one.
We've explored how LLMs can understand graph data,
Right.
the importance of those encoding methods, the challenges we face,
Yeah.
and all those incredible real-world applications that are just on the horizon.
It's an exciting time to be following this field.
It really is. And keep in mind, this field is constantly changing, evolving.
Yeah.
We're going to see even more groundbreaking advancements in the near future, I'm sure of it.
So stay curious, everyone. Keep exploring.
Because the future of AI is quite literally connected.